Right. What happened there? That's too bright. All right, level 2 chem and science, I should say. Chem and science. Got a mixture. Let me do a couple of these polyatomic ones because I see you guys are just assuming 0 and it's not 0. Let's do some oxidation math to figure it out. Okay. I will do these 3, so 9, 10, and 11. Does that sound like a good plan? That'll give you a lot of examples to use. All right, so this number 9 is, I want to say nitrate, so NO3 minus. And they want you to find the oxidation number of the nitrogen and the oxygen. Now, when we look at our oxidation rules, the first thing that I notice when I'm looking through here is that there's some general rules about monoatomic and elemental form. There's also some specific rules for things like oxygen and hydrogen. Now, when I'm looking at this example over here, and I'm looking at the nitrate, there's nothing on there that tells me nitrogen's oxidation number because there's no set rule for it. However, there is a set rule for oxygen, and that is oxygen is -2. The other thing I can keep in mind is that I do also have a rule that tells me about the sum of polyatomic ions. So we're going to have to do some oxidation math to figure out what the oxidation number of the nitrogen is. So again, we set it up like an algebraic equation. So nitrogen's my unknown plus my 3 oxygens. And again, remember, I'm just going to write oxygen as OX, so that way we can distinguish that it is oxygen and not me writing 3O. And those two things together make my nitrate. Are we okay so far? I translate that then across to the oxidation number rules. So there's nothing for nitrogen, so nitrogen becomes my X, my unknown. For my oxygen, I know that it is 3 of them, and the oxidation number for oxygen is -2, except if it's in peroxide, which it's not in. So I'm going to use the -2 number, so 3 times -2, and I'm allowed to set that equal to -1 because the sum of the polyatomic ions is equal to the charge of the ion. So I set that to -1. So then I have X plus -6 equals -1, plus 6 to both sides. 6 cancels out. X equals +5. So nitrogen's oxidation number in this case is +5. Huh? So the rule is that for polyatomic ions, the sum of the oxidation numbers equals the charge. So the charge in this guy is -1. So the overall charge is -1 when I do this math. Sorry, the polyatomic ion is -1. So I'm setting it equal to -1 to the charge of whatever that is. So when I go to fill in this guy over here, nitrogen's +5, oxygen's -2. No. So if oxygen's in the elemental form, it is 0. If oxygen is in hydrogen peroxide, it is -1 instead of -2. And then if it's with fluorine, it's +2. But it shouldn't be in the examples that I give you. Are you okay with that? All right. I'll give 2 more examples because I know you guys are like, what's going on? All right. We'll do the nitrogen dioxide. So that's NO2. Again, nitrogen isn't a specific thing on my list, so I have to do oxidation math to find it. So it's going to be N plus 2 oxygens makes the nitrogen dioxide. Let's add in the oxidation numbers that we know. So X becomes the unknown. I have 2 times -2 because my oxygen's in a molecule, so it keeps to that -2 rule. And I set it equal to, in this case, 0, because oxidation numbers in a molecule equals 0. And this is a molecule. There's no charge on this guy. Yeah, I need to set it to 0. If there's no charge on it, then just set it to 0. And then X plus -4 equals 0. plus 4 cancels out. X equals positive 4. So nitrogen in this case is positive 4. So then when I go back to this sheet, I would write positive 4, negative 2. And I'll do the dichromate because the dichromate one's tricky. One last example. Just watching the time. Okay. The last example is my dichromate. So I have Cr2O72 minus as that molecule. Sorry, I should say that polyatomic ion. So I have 2 chromiums plus 7 oxygens, and together that becomes our dichromate. Agreed? Again, when I look at my rules, there's nothing on here for chromium specifically. So that's going to be my unknown and my X value. Now, since I have 2 chromium atoms, I'm going to go 2X. Plus oxygen. Again, that oxygen is not in peroxide, so it's going to be negative 2, and it's not in the element form. So again, it's going to be negative 2. So 7 times negative 2. And I'm setting it equal to the charge of this polyatomic, so setting it equal to negative 2. Yeah. Yes. So, like, for example, if we look at our resource sheet, this guy's 0 because that's an element. Or we did this one. NO2 is 0. SO2 is 0 because there's no charge on there. But if there's a charge on there, then I have to set it to charge. All right, so I have 2x plus negative 14 equals negative 2. I add 14 to each side. That cancels out. I have 2x equals positive 12. Then I divide by 2. 2 cancels out. X equals positive 6. So the chromium is positive 6. Do you want me to backtrack? Okay, where do you want me to backtrack to? Okay, so 2 times 7, negative 14. I put the 2 down. I pulled the 2x down. I added 14 to each side. So the 14 cancels out. And 14 minus 2 is 12. But I still have 2x because there's 2 chromium atoms. So in order to get rid of the 2, I divide both sides by 2. So I'm dividing it by 2 to get those 2 to cancel. If I do 12 divided by 2, I get 6. I would divide by 3. Yeah. Yeah. So chromium is positive 6. So then when I go to write it on here, I go positive 6, negative 2. Hopefully that makes more sense. All right, I'll let you guys keep going on it. Got a couple more minutes. What I will do is I'll assign this as your homework, and I'll put a pause on what I have for the next lesson as our homework. We'll do 2 lessons on oxidation numbers. Anyway, give this a go.